ఫోన్ చేస్తే మాట్లాడాను. Very good morning, one and all. Hello. Hello.
Good morning, sir.
Good morning. Hello.
Good morning, sir.
Hello. Voice.
Good morning and good morning.
Hello.
Hello.
I'm audible.
Yes, sir. Yes, sir.
So, all of you from, I think, from different study centers. My name is Dr. Vijay from Hyderabad. I'm assistant professor of contract at Hyderabad headquarters. I'm teaching with Algebra. So, how many units completed in your study center? Let you know. I'll let you know how many units completed. Please respond. It is a mathematics class. You can reciprocal, then only I will speak. Hello? వినబడుతుందండి నా వాయిస్? Unmute and speak, then I will start the class. Yeah. Tell me one by one, tell me.
What, sir?
Which study center you belongs?
Rajmundry, sir.
Okay, how many units completed, sir?
Sir, I have not attended any class, sir.
Okay. Anyone, please respond. Yes. Anyone, please? Anyone?
Sir, two to three chapter completed, sir.
Which study center, ma?
Nizamabad.
Okay. Okay. 2 to 3 units. Any more? Hyderabad center is there? Hyderabad study center? Hyderabad study center? Hello? Please speak, please speak. We shall begin, Andy. So, Malleshwar, very good, Andy. The screen is visible for all of you?
Yes, sir.
Yes, sir.
Okay, okay. We will discuss some chapters, beginning of the chapters. So then we will go to the important topics. So some more units not covered in the different centers. So I will start with some more exercises, problems, and all these things. So I will write here. It is visible, all of you?
Yes, sir.
Okay. Shall I will write on the screen? You can. So we will do that one problem here today. Prove that. Yes, yes. Any doubts? Ask me after the problem. I will tell. Prove that a subset non-empty, not empty, non-empty. Have writing here H of a group. G is a subgroup if and only A belongs to H, B belongs to H. That's I will write A B inverse to belongs to H. So we are writing it. What is, anyone tell me what is non-empty? What is a subset means? Anyone give me the answer subset? Hello? Please respond, Andy. Anyone respond, please? What is the meaning of subset?
Element of set is in other set.
Amma, again tell me.
Some elements of in some set is in another big set.
Okay.
Is called a subset.
Okay. Anyone, another, anyone, please? So this is a, so H is a non-empty subset of a group. G means it is a group. So we can write here H is a subgroup with respect to operation G. So what is operation G? H is a group. Suppose H is a group. H is a group. The operation is closed. So H is a group. The operation is closed. So H is, we can take that the group, then the operation is closed here. So therefore H is so therefore we can write here A comma B belongs to H. We can write A comma B belongs to H. We can write it or not? We can write it or not? Respond కావాలండి మీకే చెప్పేది. Hello? A comma B belongs to H. We can write A comma B belongs to H. Suppose H is a group. For every A belongs to H, we have. So we have to take here A inverse belongs to H. B belongs to H. We can write B belongs to H, that is B inverse belongs to H. We can write it or not?
Sir.
Yes, sir. Yes, sir.
Please respond, all of you. I am telling
Yes,
you
sir.
the.
We can write. Yes, sir.
Yes, very good, very good. So A belongs to H and B inverse belongs to H. And we will write this one also. This is B inverse belongs to H. So therefore A belongs to H. Therefore the conditions may be written here. So therefore, this is the condition. So therefore, A belongs to H and B inverse belongs to H. We can write AB inverse belongs to H. So we can write from above equation. We can write it or not?
Yes, sir.
Very good. Very good. Itla respond అవుతుండండి. ఎక్కువ చెప్పడానికి నేను ట్రై చేస్తా. So converse, we can take the conversely function here. So AB inverse belongs to H for all A comma B belongs to H.
Belongs to H.
Yes. So therefore H is a non-empty non-empty we can write here. We can choose H, capital H, small h belongs to H. What is small h and capital H? Anyone tell me?
H అనేది ఒక గ్రూప్ సార్, అందులో ఒక ఐడెంటిటీ ఎలిమెంట్ అనేది స్మాల్ h సార్.
The small h is elements. The
Yes,
small
sir.
h is element. The capital H is the
Group, sir.
what is the element? Exactly. What is the small elements? It is in the group. What we are writing H here. Am I correct?
Yes, sir.
So therefore, now you are understanding my portion.
Yes, sir. Yes, sir.
Yes. The associative law holds. The associative law holds. H has it holds in G. H has holds in G. So therefore, associate what we are reading here, A plus B plus C
A plus B plus C
is equal to A plus
B plus C.
Very good. In the multiplication, A star B star of C, A star of
Yes,
B
sir.
star of C. So what
Yes,
is of inverse? I am writing here. A belongs to H.
A belongs
B
to
inverse,
H.
A inverse is equal to A
belongs
inverse.
to H.
Dot E we can write. We can write dot E.
Yes,
Why?
sir.
Because this is the identity element.
Identity element. Yes, sir.
Very good. Yes, that way we can write A comma E belongs to
A
H.
comma B belongs to H.
A comma E belongs to H. So therefore, A comma B belongs to H. We have A inverse and B belongs to H. So therefore, AB is equal A inverse of inverse belongs to H. It is a, what is this property? It is a closure property or associative property?
This is closure property, sir.
Why?
A inverse closure.
So A inverse
Yes,
of
sir.
inverse is a A.
A, sir.
A inverse of inverse A. That is a closure property. So therefore,
Yes, sir.
H is
A belongs to H, sir.
a subgroup and
Subgroup of
hence H is a subgroup of G.
G.
It is correct?
Yes, sir.
Any more doubts? Ask me.
No more doubts, sir.
No, who are speaking? Evarama, పేరు చెప్తారా?
నా పేరు తులసి సార్.
Which study center?
రాజమండ్రి.
Very good. అర్థమవుతుందా అమ్మా?
అర్థమవుతుంది సార్.
Okay, then please mute అండి, మాట్లాడని వాళ్ళు mute చేయండి please. Define a cyclic group. Prove that a subgroup of a cyclic group is also a cyclic. So we can, what is this? Anyone tell me the cyclic group? A power n by n. A power n by n is an integer. It is correct. What is this one? Anyone tell me? What is this? Tell me, anyone? It is what is the symbols and what we have to writing here? It is generators of A.
it
Tell me. Anyone tell me?
డిఫైన్ సైక్లిక్ గ్రూప్ అంటే ఈ ఏలో ఉన్న ఎలిమెంట్ ఆ జి అనే గ్రూప్ లో ఉంటుంది సార్. అప్పుడు అసోసియేటివ్ ప్లస్ 5 లాస్ కూడాను దానికి ఇది అవ్వాలి.
Definite. What is the, how we can pronounce it? This is a, what is the generator of it is?
Cyclic.
How we can pronounce it?
It's generated, sir.
That's why I'm asking.
He is a generator by A.
A. It's a generator of A. It is equal to G. So therefore, G is a generator of group. If and only there exists, A belongs to G. So
A power K.
G. So therefore, we are writing G is equal to generator of A. That means A power n by n is an integer. A power n by n is an integer. What is the meaning of integer? Anyone tell me?
Which consisting of whole numbers.
Yes.
And positive numbers. I mean negative numbers. Whole numbers and negative numbers, sir.
What is your name?
Rajarajeshwari, sir.
Study center?
HTML block, sir. PG Study Center, Hyderabad.
Okay. You are listening my class in the offline?
Yeah, sir. Yes, sir.
Generated by. That's why you are speaking very fast. Okay. Let J be a cyclic group generated by A. So I am writing here. Ranjit, what is your doubt? Ask me, Ranjit. Ranjit, raise your hand. What is your doubt? Okay. You can direct ask. Don't raise the hand. G generator of A is equal to A power n by n as an integer. So A power n by n as an integer. So we can take that H be any subgroup of G. We can write it as any subgroup of G. Means this is the subgroup of G. We can write here. Now every element H is an element G. Hence integral or integer of power of A of we can write here. So therefore every element of H we can write here. Every element of H is every element of H is A power n for some integer. N. And every element of H. So every element of H is in A power n. Some integers we are already told that is the integer of n. You are understood? Hello? Hello?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Anyone respond, then only we can clarity. So therefore, how we have to prove that? To prove that we have taken here H is equal A power D. We can write here H is equal to A power D. So let X be on arbitrary element in H. X is equal to A power m belongs to Z. X is equal to A power m belongs to Z. So therefore we have to take any arbitrary. What's the meaning of arbitrary element? Tell me. Arbitrary element. Tell me. I'm listening. Hello, I'm audible. Arbitrary element simple means an element not chosen. So the perspective of that element choose randomly and unpredictably. Suppose consider X a set of 1, 2. Probably X might be the value 1 or 2. So it is a before that which one it will be. Am I correct? Hello. Let X be an arbitrary element H. X power n belongs to Z. So by division algorithm.
Sir, your voice is breaking.
Now okay. Now okay.
Yes, sir.
So what is a arbitrary element means? Element not chosen by you. Suppose it is a perspective. The element we can choose randomly and unpredictable. That means set 1 of 2. which one it will be? Am I correct? Hello? By division algorithm, we have to take here. What is this symbol? Anyone tell me?
There exists.
Very good. Very good. Arbitrary element winner.
Yes, sir.
Respond Q, R such that we can write M is equal to D plus R is equal to 0. So R 0 less than R less than D. So therefore we can write here A power M is equal to A power DQ DQ plus R. So we can write here A power DQ into A power R. So therefore write A power DQ is, I am writing A power M, and A power minus DQ I am writing here. So therefore we can write A power M minus DQ. We can write it or not? A power DQ plus R. DQ and NT.
M power.
M.
M power N.
M. A power M. A power R means what we have to write? Negative value. Negative value.
Okay.
So therefore A power M minus DQ. A power M minus DQ is equal to A power R. M minus DQ. M minus DQ. Here M is equal to DQ plus R. I am writing DQ plus R. So therefore M minus DQ is equal to what is that value? R. So therefore M minus DQ is equal to what we have to write here?
A power R.
A power. So that therefore A power R we can write here. So therefore we have A power D belongs to H. So A power D whole power Q is equal to A power minus D power Q belongs to. We can write it or not? We can write it or not?
Yes, sir.
Yes,
We can
sir.
write.
Yes, sir.
తప్పు రాసినప్పుడు మీరు రెస్పాండ్ అవటం లేదు, అందుకనే మళ్ళీ రాస్తా. A power minus D. So therefore A power M into A power minus DQ belongs to H. We can write that is A power R belongs. That means MQ, that values in that one. Therefore we can write A power R belongs to H. So where we have to 0 less than or less than D, we get a contradiction to the choice of D. So therefore R is equal to 0. Therefore M is equal to DQ. Therefore X is equal to A power M and A power D whole power Q we can write here. So therefore every element of integral domain of A power D is correct. As per these conditions, every element of H is in integral domain. It is correct or not? Huh? As per this, every element of H is integral power of D. A power D is correct or not?
Yes, sir.
Yes. Why? Because we are doing M is
Power.
M is equal to DQ plus R. M minus DQ is equal to R. So that is the element of A power D. It is or not?
Yes, sir.
So the A power D is generator of H. A power D is generator of H. So we can write here A power generator of D is H. So therefore, we can write here H A less AD. H is a cyclic. H is a cyclic group. So therefore every subgroup of a cyclic group is cyclic group. The condition is correct or not?
Yes, sir.
So, any more doubts? Ask me. I will clarify. Any more doubts? Ask me. I will clarify. No doubts?
So please tell me about arbitrary element.
Arbitrary element. Again, listen me. Arbitrary element. Arbitrary element means simply means an element not chosen by us. For the program perspective, an element chosen randomly. Randomly means what? Tell me. any numbers unpredictable, consider x is equal to set 1, 2. That my x is might the value 1 or 2, but you cannot predict beforehand which one it will be. Manam predict cheyalemu. Avuna kada? Hello?
Okay, sir. Okay.
Clear?
Okay, sir.
Right. Any more doubts? Any more, please? Okay.
Sir, variable type, na?
Huh?
Variable type. Okay, thank you.
State and prove the fundamental theorem of homomorphism of rings. Suppose F is an homomorphism. What is homomorphism? Tell me anyone. What is homomorphism?
1, 1 and on 2.
Very good. What is your name?
Sandhya, sir.
Center?
Hello.
Which study center?
Hello.
Hyderabad Study Center.
Yes, sir. Yes, sir.
Okay. Homomorphism of rings. So therefore we have to take here. I am writing the statement, very important. So I am writing the first statement. Suppose F is a homomorphism of a group capital G into a group G bar, then G by kernel F is equal to imaginary F, IMF. So therefore F is onto, then G by kernel F, G bar. So this is a statement. So I am taking here, this is the statement. State and prove the fundamental homomorphism of rings. Suppose F is a homomorphism, 1, 1 and on, you told that F is on to, F is on to means 1, 1 and on to. Therefore G by kernel F is equal to G bar. Now I am taking the proof here. Very seriously listen, and I will any doubts and ask between the I will ask the questions also, please. So we have F of G to G dash is a homomorphism of a group G, capital G, onto a group of G bar. Am I correct? It's a homomorphism, therefore it is a group of G. So therefore we can take that N is equal kernel F and K is equal image of F. N is equal, we can take the kernel F and K is automatically. What is image of? Anyone tell me? What is image of F? Hello?
Codomain of domain element.
Codomain of domain element. Very good, Sultana. So therefore, now it is an image of F. Then we are writing here. We know that N is a normal subgroup of G, since kernel is always a normal subgroup. Kernel is a normal subgroup and K is a subgroup of G. Am I correct? So N is a normal subgroup of G. So therefore the kernel is always normal subgroup. Therefore K is a subgroup of G bar. Now we can consider here. What is a quotient group? What is a quotient group?
Fraction group, sir.
It is a, we can write G by N.
Yes, sir.
Very good.
Yeah, sir. G by H or
Yes,
G
sir.
by N.
Yes, sir.
Yeah, H means it is normal subgroup that I'm writing
Normal
G by
subgroup, sir.
we can
Yes,
write it
sir.
or not. Raskochu by G.
Yes, sir. Yes.
G n of A is equal F of A. We can write it or not.
Sir.
G n of A is equal to F. So now we can prove here G is well defined, G is homomorphism, G is onto, G is 1 1. These four we have to prove. Then it is called, it is the fundamental theorem of homomorphism. So first I will let us prove here. అర్థమవుతుంది అందరికి?
Yes, sir.
Prove that G is well defined. So first one, NA is equal to NB. What is N? What is N? What is N? What is N and D?
Normal subgroup.
మరి చెప్పాలి కదా. AB, what is that? That is a variables or elements?
Elements.
Elements, sir. Elements.
Very good, very good, very good. Immediately respond kavalandi. Very important this question. NA is equal to NB for some A comma B belongs to G. So therefore, NA is equal to NB. We can write that is AB inverse belongs to N. We can write it or not?
Yes, sir. Yes.
This is called kernel F. As per the earlier theorem, we can write kernel F. F of AB inverse is equal. This identity we can write where E bar is identity in H. Am I correct?
Yes, sir.
F of A is equal to F of A into F of B inverse is equal. This is E bar. F of A into F of B inverse is equal to E bar.
Yes, sir.
Why? Because it is identity. So
Yes,
therefore, yeah, from the homomorphism, F of A into F of B inverse is equal to E bar, and also F of A into F of B whole inverse also E bar. So both from F is homomorphism. Am I correct?
Yes, sir. Yes, sir. Yes.
Yes, sir.
మాట్లాడే వాళ్ళు మాత్రమే క్లాస్ లో మాట్లాడే వాళ్ళు మాత్రమే అన్మ్యూట్ చేసుకోండి. మిగతా వాళ్ళంతా మ్యూట్ లో ఉండిపోండి. మీ ఇంట్లో వాయిసెస్ వినబడుతున్నాయి. ప్లీజ్ రంజిత్.
Sir, your voice is breaking, sir.
Not my voice is very clear.
Yes, sir.
You are from your side disturbance 4-5 members is not unmuted. In your house voice is there. Those who are Nagendra, tell me. Karma, tell me.
No, sir. I'm unmuted.
Okay. Listen here. I know that you will. Don't about it. F is homomorphism. So therefore here F of A is equal F of B. So therefore Gn of A is equal Gn of B is equal. It is well defined. Why? Because well defined. F of A inverse F of AB inverse is equal to E bar. Therefore G is identity. F of A into F of B inverse is equal to E bar. And also F of B whole inverse also. Both the conditions are from homomorphism. So therefore G of natural of elements Gn of A is equal to Gn of B. Well defined. Why? Because it is belongs to kernel F. Am I correct or not?
Yes, sir.
Very good. Then we'll
Yes,
go
sir.
to we will go to the second one. G is a homomorphism. Varma, you are understanding?
Yes, sir. Understanding.
I'm seeing your face. Don't worry.
Okay.
X comma Y.
Sir, voice break అవుతుంది, sir.
ఇప్పుడు ఓకేనా?
My voice is very clear.
X comma Y belongs to N.
Yeah, now it's okay, sir.
I'm not using mobile net. I'm using Wi-Fi. You don't worry about it. XY belongs to G by N. So therefore, A comma B belongs to G such that X is equal to NA, Y is equal to NB. We can write it or not? రాసుకోవచ్చు అండి?
Sir, yes.
రాసుకోవచ్చు. X comma Y belongs to G by N అంటే X is equal to NA, Y is equal to NB. From the earlier of is well defined. So now I am continuing here. G of XY is equal to G of NA continuation. G of NB is equal to G of NAB. We can write it or not?
You can write, sir.
N is a normal subgroup of G. N is a normal subgroup of G. That's why we are writing here. So therefore we can write here f of AB. So therefore we can write f of A into f of B. We can write that not. So what is why we can write from the definition of G, from the definition of G. Definition of G where f of AB, from f of A into B we can write this is f is homomorphism. Avuna kada?
Yes, sir.
F is homomorphism. So therefore Gn of A, Gn of B is equal to G of X into G of Y. We can write a Gn of A is equal to Gn of B is equal to G of X, G of Y.
Yes, sir.
Yes,
Why?
sir, yes, sir.
Why? Because Gn of A now.
G of N.
Normalize it.
Yes, I am written here.
Normalize it.
G of X comma normal. So therefore we can write
Normal.
so now it is homomorphism or not?
Yes, sir.
So X comma Y belongs to G by N. So therefore G by N, the condition is it is homomorphism. The third condition, G is on to. I'm writing here X bar belongs to H, then there exists.
Sir, first screen కొంచెం down చేయరా sir, last point. Okay sir, thank you sir.
రాసుకుంటున్నారా?
Yes sir, yes sir.
I will share this all these things in the last day.
అవునా? Okay sir, okay.
Okay,
Okay,
don't
sir.
worry. Listen first.
Yeah, okay sir, thank you.
That's why I taken the board. Therefore, X belongs to G. So such that we have to write here f of X is equal to X bar. We can write it or not? రాసుకోవచ్చండి?
Yes sir, yes sir.
So this is f is 1 or on to? Varma, it is on to or not?
Sir.
It is on to na? 1 na?
On to sir.
On to, sir.
1 is already we learned in the homomorphism condition.
Yes, sir.
Yes, sir.
మరి చెప్పరే, నాకు రానప్పుడు చెప్పాలి కదా. Therefore, f of X is equal to Gn of X. So therefore, X belongs to H. There exists Nx to G by N such that Gn of X is equal to X bar. From that Gn of X, G by N, X belongs to R. So G is on. Therefore, G is on to 1
On to.
On to, sir.
Oh, very good. On to. So therefore, next prove 1. G of I, we can write it or not?
Yes, sir.
G of N of B is equal to, we can write it or not?
N of P.
Y
Yes.
is equal to N of A, B belongs to G
N
by
of
N
A
or
is
not?
N of P.
We can write it
Yes,
or not?
sir.
Therefore, f of
Quotient,
A is
yes.
equal to what we have to write? F of B, we can write it or not?
F of B. Yes,
F
sir.
of A into F of B inverse. We can write E inverse or not? E dot
E
or
inverse.
not?
Yes, sir.
That F of A, B inverse of E bar, we can write it or not?
E bar.
AB belongs to,
Yes.
so therefore from above condition AB inverse
N.
belongs to N. So therefore NA is equal to NB. So therefore
NB.
therefore X is equal to, we can write it or not?
Yes, sir.
Therefore
Hence
X
it is 1
or not?
Yes, sir.
What you have proved? 1 on to
Onto
homomorphism, well defined. The
homomorphism.
4 conditions are satisfied or not?
Yes, sir.
So therefore 4 conditions are satisfied here. G by N H is a homomorphism 1 and on to. So therefore G by kernel F image of F. It is condition are okay or not?
Yes,
Yes,
sir.
sir.
So G by kernel F, that is H. So therefore, n is equal to, we can write here. Can I, it is correct or not?
Yes, sir.
So the
Sir.
these four conditions are satisfied. It is correct.
Yes, sir.
Any more doubts? Very most important theorem. You can ask any doubts. I will clarify.
Fundamental theorem.
Any more doubts? Ask. I will clear the doubts, please. All of you understanding? First of all, tell me.
Yes, sir.
ఒక్కరికి అర్థమవుతుంది.
Yes, sir.
రెండు.
Yes, sir.
Okay. But don't, Verma, don't give me reply anyone. Only 1, 2 students reply. That's why I'm asking it. Okay. Yes. Now I will go to another very important theorem. Prove that every group of prime order is cyclic. Prove that every group of prime order is cyclic. What is the meaning of prime order? Anyone tell me? Hello?
2, 3, 5.
Maybe elements of group
is a prime number?
Yeah, sir.
Yeah. Yes, sir.
Very good.
Yes, sir.
Let 3 greater than 2 be a prime number and G be a group such that modulus of G is equal to P. P means the prime number?
Yes.
It's the number of elements in at least 2. One of the elements of G will different from the identity of G. Let that element let the generator of A. So that the cyclic groups of G is generated by A belongs to generator of A. We can write here generator of A is equal to of identity or not equal to of identity.
Yes.
It's equal to identity, sir.
ఎట్లమ్మా నువ్వు ప్రైమ్ నెంబర్
డివిజర్స్
అవునమ్మా ఇది ప్రైమ్ నెంబర్ అంటున్నారు మళ్ళీ ఐడెంటిటీ ఎలిమెంట్ కి ఈక్వల్ అంటున్నాము ఈక్వాలిటీ ఇస్ కరెక్ట్
You should have another element, sir, that is prime number.
I am asking a very straight question.
Not only element, identity element.
What is your name? What is your name?
Sandhya, sir.
Tell me, Sandhya.
Okay. We want another prime number that is, sir, not only identity element, sir. One more element should have that.
So then we suppose only prime element. It is
yes,
equal
sir.
to element or not equal to identity element?
Equal to element. Not, sir, not every time. I mean.
Now tell me, I'm listening.
It must have identity element also, sir. But one more element.
Exactly, Divya. What I am telling. Generator of A not equal to E or equal to E?
Not equal to.
X power n equal to E, sir.
Yes.
X is the
order. Sir, here we have to consider order of that element, sir.
Yes.
Order of that element, sir, in the group.
Yes, agree. It is equal to or not equal to? I am asking.
Equal to only, sir.
No. Why? No. Anyone tell me?
Sir, as per the order, it should must at least one positive integer should exist, sir. Like as we know, 8 power of n is equal to E. As per order of an element of the group.
Rajeshwari, A belongs to, I'm asking again, telling you, A belongs to, that is a generator of A, that elements. So generator of A is equal to identity of elements should be satisfied for all elements. No?
Not all elements.
Not all. That's why I'm not equal to, I'm telling.
Okay.
Am I correct?
Yes, sir.
Now clear, Rajeshwari?
Yes, sir.
Now I'm telling the continuation, you can observe here.
Yes, sir.
Let A have order H. Lagrange's theorem I don't tell H is equal to 1 or P. So therefore that is order of H is P. Therefore that is not equal to P. Why? Because H is equal to not H not equal to 1 and H is equal to P. Now clarified?
Yes, sir.
Now order of A is equal to P. So therefore is equal to G. So therefore G is a cyclic group. Therefore G is a cyclic group. Clear? Clear? Any doubts?
Sir, please repeat here, no, sir. I mean,
where, Amma?
Like generator of A is equal to E.
Amma,
not equal
all
to E.
what prime numbers we are taking?
Not,
prime numbers we are taking.
Okay, sir.
Clear? Huh?
Yes, sir.
Very good. Then, any more doubts? Ask me, Varma.
No, sir. Clear, sir.
Very important. చెప్తున్నాను ప్రతి యూనిట్ నుంచి ఓకేనా?
Right, sir.
అన్ని యూనిట్స్ కావాలంటే కావు మరి. Anyone tell me what is the Cayley's theorem? Cayley's theorem, Cayley-Hamilton theorem, both are same.
No, sir. No.
What is it? What is it? Cayley-Hamilton means I know that A11, A22, A33, A11, A12, A13, A21, 22, 23, 31, 32, 33, and so on, 1n, 2n, 3n in the rows. So the 3x3 matrix you can call as Cayley-Hamilton theorem. Am I correct? What is Cayley's theorem? Anyone knows? This is the third unit or fourth unit. Every group G is isomorphic to a subgroup of S of X of permutations on X for suitable set X. This is the statement. Every group G is what is the meaning of isomorphic? Anyone tell me?
Sir, it is 1-1 onto and homomorphism also.
Very. And what is automorphism also? Is there?
Automorphism, yes, sir.
Unda automorphism?
No, sir.
Yes, sir. Yes, sir.
Isomorphic means it? Huh? Tell me. Rajeshwari, tell me. What is isomorphism?
Isomorphism group.
What is isomorphism definition?
A mapping of 1-1 and onto mapping.
1-1 and
onto mapping of homomorphism is called isomorphism.
It is a binary relations or not?
Yes.
So in isomorphism, 1-1 correspondence between two preserves the binary relations between the elements. So the natural numbers can be mapped on the set onto the set. Natural numbers multiplying the natural numbers by 2. Am I correct or not?
Yes, sir.
So I am going to the proof. Let G be a group. X is equal to G itself. A belongs to G. Define T of base A. G belongs to G by T of G. Sorry. T of A. T of A. It is a G into G. G to G. T of A. G. That is, we can write AG for every G belongs to G. So we have to prove that TA belongs to SX. That means T of A is a permutation. Don't leave the class. Is a permutation. X is equal to G. X is equal to G. All of you understanding?
Yes, sir.
Okay. X is equal to G. So therefore, so in this condition T of X is equal to, we have to, here also 1, 1 and on 2, and the TA circle TB is equal to TB. Homomorphism T is 1, 1. We have to prove 5 conditions. Then it is a proving of Taylor's theorem. So now I am going to the first condition. Just a minute, please. Stay on the line, all of you. To prove that TA is 1, 1. TA is 1, 1. Suppose I am taking G comma H belongs to G. Let TA G. We can write it.
Yes, sir.
From the theorem, X is equal to T of A to G is equal to T of A H. We can write it or not?
Yes, sir.
AG is equal to H. We can write it or not?
Yes, sir.
G is equal. What is A?
H1.
What is A here?
Element of T.
Yes,
Elements.
elements. Very good. Therefore, G is equal to H. We can call this is a left cancellation law. A cancel here. So therefore, G is equal to H. So therefore, it is 1, 1 or it is 1, 1 or not?
1, 1, sir.
It's okay. So therefore, T is 1, 1. Enta simple chusara. T is 1, 1. Then we are going to second one. TA is on. G belongs to G. What is codomain? Anyone tell me what is a codomain?
Group second group.
Exact definition I want. Codomain.
Image of domain, sir. Image of domain, sir.
The codomain means our set of destination of the function, which is all output of the function constraint to all. That means set y in the notation, y is equal to x tends to y. The range sometimes is used to either codomain or image of the function. Ante first dantlo unnatuvanti then second daniki teeskuntam. Am I correct or not?
Yes.
But cheppali kadamma. So therefore, a G belongs to G codomain we are taking here. So therefore, A inverse belongs to G codomain such that we are taking TA A inverse G. So therefore, AA inverse G, AE inverse G we are writing here. AA inverse, that means identity element or not?
Identity element, sir.
So therefore,
Yes,
EG is equal to G. VG is equal to G. We can write it or not?
Yes, sir.
So this is identity element. So that is a function. TA is onto or not? Anyone?
Onto.
So TA is 1, 1 and onto. 1, 1 and 1, 1 and onto. So therefore, it is a 1, 1 and onto. It is a permutation. TA is a permutation of X or not?
Yes, sir.
So we can write here. Just a minute. Therefore, TA is permutation of X. Am I correct?
Yes, sir.
Yes, sir.
So therefore, TA belongs to Sx. Third condition, we now prove that. All of you understanding?
Yes, sir.
T circle A of B is equal to T of AB. For any A comma B belongs to G, we have T circle A of T circle B. T A of T. We can write this one. This type of we write.
Yes, sir.
Very good. Very good. We can write here. Therefore, here T of A. We will remove the T. We can write BG here. We can write ABG also. Am I correct? T A of B of G. We can write this is for every G belongs to G. What I am taken? T circle of A, T circle of B, T of A, T B of G. So I'm writing BG. Then T will remove ABG. So again, you are applying T base of ABG for every belongs to G. So therefore, T a circle TB is equal to T of AB. It is correct?
Okay, sir.
Okay na? Correct?
Correct.
మళ్ళీ ఇక్కడికి పోతాం. ఓకే అంటే ఏదో మొక్క బోడిగా చెప్పినట్టుంటుంది ప్రాబ్లం.
లేదు సార్, వాయిస్ బ్రేక్ అయింది. నెక్స్ట్ స్టెప్ వినేసరికి ఓకే అన్నది.
ఓకే, డోంట్ వరీ అమ్మా. Prove that 5 is on homomorphism. Prove that 5 is on homomorphism. For any A comma B belongs to G, we have phi of A comma B is equal to T of A comma B. Avuna? Phi of A comma B, we can write T of A comma B. We can write it or not?
Yes, sir.
Yes, here. So phi of A, phi of B. So therefore phi of AB is equal to phi of A circle phi of B. So therefore that is A comma belongs to G. We can write it or not?
Yes,
In place of T circle
Yes,
of A, T circle of B, we can write phi circle of A, phi circle of B.
Phi of A.
Phi of AB is equal to phi of A circle of phi of B. So therefore the phi is homomorphism. Then another law, 1-1 condition. Phi is 1-1 condition. Phi of A is equal to phi of B. What phi of A? Phi of B means T of A is equal to T of B, huh?
Yes, sir.
T of A of X is equal to T of B of X, sir. A of X is equal to AX is equal to BX, sir.
Yes, sir.
Therefore A is equal to
X is equal.
A is equal to B. So phi of A is equal to phi of B. So it is 1-1 or not?
1-1.
Yes, sir. 1-1.
So it is a phi is homomorphism or not?
As homomorphism.
Yes, sir.
Phi of G is equal to T of A by A belongs to G is a subgroup of
G.
Subgroup of S of X. So therefore phi of G is an homomorphism. Oh na?
Yes, sir.
So therefore G, all the conditions are satisfied. So G is isomorphic with phi of G of phi of S of X.
S of X.
Any more doubts? Ask me. Any more doubts? Ask me. మిమ్మల్ని ఏం డౌట్స్ ఏం లేవా? నువ్వా? ఎనీ మోర్ ప్లీజ్? నో మోర్. ఎనీ మోర్ ప్లీజ్? ఎనీ మోర్? ఒకరిద్దరే మాట్లాడుతున్నారు, మీతో ఎవరు మాట్లాడారు అంటే ఏమో మ్యూట్ చేసి వెళ్ళిపోయారేమో అనిపిస్తున్నాను నాకు. Just ask me, connecting audio something. Yes, Varma and Monica.
Sir, screen not close. Sir.
Yes, I am close to the screen.
Okay.
Doubts gurinchi close చేస్తాను. Now I am. ఇప్పుడు ఓకేనా?
Yes, sir. No problem.
Yes, sir.
I need ask me doubts. No more. No more. No.
Understood, sir.
Okay, thank you. State and prove the cancellation laws. A group. Ask me.
Sir, disconnect అయ్యి కనెక్ట్ అవుతుంది సార్. మరి
మీదే ప్రాబ్లం, నా దగ్గర ఫుల్ ఉందండి వైఫై.
లేదు సార్, ఇక్కడ కూడా ఉంది.
నా దగ్గర 150 MBPS నడుస్తుందండి.
లేదు సార్, మీ డిస్కౌంట్ అవ్వట్లేదు, మీది వాళ్ళ దగ్గర ఉంది.
అదే వర్మ, నేను దీని గురించి క్లాసుల గురించే పెట్టించా 150.
సార్ మీరు పెట్టుకున్నారు, అందరూ పెట్టుకోవాలి కదా సార్. అందరికి పెట్టిస్తే బాగుంటుంది సార్.
ఓకే. I am not. Thank you. State and prove the cancellation laws in a group. So therefore, let G star be a group. G star be a group. So therefore, A comma B belongs to G. So that the following the condition may be true. So therefore, A star B is equal A star C. So therefore, B is equal. So we can write it or not?
You can write it, sir.
Yeah, what is the law? There is a left cancellation law or right cancellation law?
Left cancellation.
Why?
Cancellation.
Why? Because the A is the left.
Left.
Yes.
Left.
Therefore,
Yes,
therefore the
sir.
left
Place in
cancellation law
yes.
this is in
Yes.
place of A. Now I am writing. This is left cancel LCW, left cancellation law. A star B is equal to C star B. What is this?
This is right cancellation, sir. Age
Right
group.
cancellation law. Right cancellation law. B is there. My right side B
Yes,
is there.
sir.
So we are writing the right cancellation law. So they are asking. It is a we have to prove. This is the statement. Now I am asking the proof here. And I am requesting you, all of you 47 members is there. Listen here. I will close the class by 12 o'clock. And immediately I will give the break 10 minutes. And today real analysis sir is not coming. I will take by 12:15 sharp again.
Okay.
Okay, sir.
12:15 to 1:15 I will take.
Okay, sir.
Okay, sir.
15, sir.
I will break with 10 minutes. Okay.
Okay, sir.
Sir, through this link, sir, or you have to join another link?
Another link.
Another link.
Through another link you have to join.
Real analysis link, sir.
Yes, I will ask and I will tell you. Just after this problem, I will
Okay.
ask. Problem I will ask.
Okay,
Don't leave until I will tell.
Okay,
Okay,
sir.
sir.
A star is equal to A star C. So therefore, B is equal to, I am writing B is equal to E star B. So I am writing, we write A inverse of A. We can write it or not? In place
Yes,
of
sir.
in place of A, I am writing A inverse of A star B. We can write it or not?
Yes, sir.
Identity
Yes,
element.
sir.
So then
Yes,
we have
sir.
to write
Yes, sir.
here A star B is equal to A star B. A star B is equal to A inverse of A star C. We can write
Yeah, sir, right. We can write. 100% we can write, sir.
100% we can write.
Sir.
Sir, C, not C, sir.
C allowed, sir.
C,
We are taking A, B, C belongs to Gina.
Yes, sir.
We are
Yes,
taking,
sir. Oh.
yes, I will write, I will tell you. A star inverse A star B we can write. Then we can write here, I am writing another step also. A star inverse of A star B. In star of B, I am taking star of C. We can write it or not?
Yes, sir.
So therefore, A inverse of star A star C is equal to E star C is equal to C. It is correct? It is correct or not? In place of B, I am taking CM. In place of B, I am taking C.
Yes, sir.
So I am applying AC. That is also identity elements of C. It is correct or not?
Yes, sir.
So therefore, the second condition I am taking here. A star B is equal to C star B. Therefore, A is equal to A star E is equal to A star of E is equal to, I am writing here, B star of B inverse. We can write it or not?
Yes, sir.
I'm writing B star B inverse. So therefore, A star of B inverse, C star of, in place of A, C star of B inverse. So C star of B inverse is equal to C star of E is equal to E. So C star of E is equal to E and A star is equal to A star E and B is equal to B star E, A, B, C are, C is called, this is the called the cancellation loss in a group. Are you clear?
Yes, sir.
Any more doubts? Ask me.
No, sir.
Clear?
Yes, sir.
Yes, sir.
Now I am going to Just a minute. I will ask the sir and I will inform you. Just wait.
Okay, sir.
లేకపోతే 12 అడుగుతాను, వెయిట్ చేయండి. 12 అడుగుతాను. 10 minutes before అడుగుదాం. Sorry. Prove that non-empty subset of S of a ring or is a subring if and only for any AB belongs to S, A minus B belongs to S, and AB belongs to S. Deduct the center ZR of a ring or is a subring of R. See here, all of any non-empty subset means any element is there. Am I correct?
Yes, sir.
So therefore, the subring is only AB belongs to S, A minus B belongs to S. So deduct that. So if A minus B belongs to S, I am writing here. If A minus B belongs to S for all, AB belongs to S, I am writing here. That is S, the group, it is addition in additive subgroup. So therefore, we can write here R comma plus. So therefore, A, B belongs to S for all. Already I told in the earlier definitions, A comma B belongs to S. It is an S comma. What is semigroup? What is semigroup?
It should satisfy all the properties of groups.
No. Only should be satisfy associative, I think. Am I correct? Huh?
Yes, semigroup, associative, yes, sir.
Closure and associate. Associate means closure should be satisfied, then only associate is satisfied. Am I correct?
Yes, sir.
Yes, sir.
Associative. Then S called S dot is semigroup. So therefore, S comma plus is a subring of R comma plus comma dot. Why? Because addition and multiplication only same. 2 into minus 3, minus 6. 3 into minus 2, minus 6. 2 plus 3, 5. 3 plus 2, 5. 2 minus 3 is equal to minus 1. 2, 3 minus 2 is equal. And addition and subtraction and division, it should not be possible. Am I correct? Hello?
Sir, yes, sir.
So therefore, conversely that, suppose it's a subring of R. So we will clearly know that A comma B belongs to S. So therefore, A minus B belongs to S. We can write AB belongs to S. That's the definition I'm writing here. Let R be a ring. Then the set J belongs to R. XA is equal to AX for all A belongs to R. E is called, it's a very important, E is called center of the ring. Center of the ring R. So say for the center of the ring R. So that it is called as a definition. So that we have to prove that the deduction here. The center ZR of a ring or is a subring or is a subring of R. Proof, we write ZR is equal to S. So S not equal to 5 because 0 belongs to S. Let A comma B belongs to S. We can write that S not equal to 0, A comma belongs to S. So therefore, A minus BX is equal to AX minus BX is equal to, we can write XA minus XB. We can write it or not?
Yes, sir.
XA minus B. So this is A minus B belongs to S or not?
Yes, sir.
Yes, sir.
So therefore, AB of x is equal A into B of x, A into x of B is equal, we can write XA into B is equal x into AB. So therefore, S is a subring of R. It is correct or not?
Yes, sir.
Yes, sir. Correct.
All of you understood?
Yes, sir.
Yeah, all of you
Yes,
understood?
Sir.
Yes, sir.
Yes, sir.
Thank you. Thank you.
Yes, sir. Yes, sir.
Any more doubts? Ask me. What I am telling is all the important for you.
Okay, sir.
Okay.
Then prove that there exists an integer. Again asking, what is integer?
It's a union
Positive
of the
and
whole
negative
numbers and the
numbers.
negative numbers, sir.
I'm repeatedly asking. Okay. See here, let P a prime number of the form 4n plus 1. Then prove that there exists an integer x such that x square is equal to minus 1 of mod P. Suppose x is equal to, I'm taking 1, 2. P minus 1 by 2. We can write it or not? Mod P means. We can write it or not? X is equal to 1, 1, 2 and so on. We can write it. That is minus. Mod P means P minus 1 by 2. P minus 1. What they given? 4n plus 1. That is P minus 1 is equal to 4n. We can write it or not? P is equal to 4n plus 1. Then P minus 1 is equal to 4n. We can write it or not?
Yes, sir.
Yes, sir.
Then P minus 1 by 2 is an even integer. So therefore we can write here x is equal to minus 1, minus 2, minus 3 and so on. Minus of P minus 1 by 2. Why? Because I'm taking minus negative numbers. We can write it or not?
Yes, sir.
So therefore, also we can write here P minus K is equal to minus K of mod P. So therefore, x square is equal to, I'm writing here 1, 2 and so on. P minus 1 by 2 and the negative numbers minus 1, minus 2, minus 3 and so on. Minus P1 minus 1 by 2 we can write here. So therefore, 1, 2 and so on. P minus 1 by 2. And this is the minus 1, minus 2. I'm writing this is a P minus 1, 2 and P minus 2 and so on. P and so on. P minus 2 by 2. We can write it or not from the above. The mod P value as per mod P value.
Yes,
So
sir.
minus 1, minus 2, minus 3 means P minus 1, P minus 2. Minus P minus 1 means P minus P minus P by 2. We can write it or not? 1, 2. That is a P minus 1 by 2 and P plus 1 by 2 and P plus 3 by 2 and P minus 3 by 2 and so on. That is P minus 1. So we are writing this total value P minus 1 whole factorial, which is called as minus 1 mod of P. So therefore, this is called x square. Mod x square is equivalent to minus 1. That is mod of P. What is this theorem? Tell me. Wilson's theorem. What theorem? Wilson's theorem. You choose to unandi. Just I will come back 2 minutes.
Okay.
I'm audible?
Yes, sir.
Okay. Sir will take from 12 to 1:30. Okay? So you join 12 to 1:30. Okay. Then now.
Sir, how it convert p minus 1 into p plus 1, p plus 3? Please explain one again.
Yes,
Sir.
tell me. Yes, tell me. Tell me.
So p minus 1, p minus 2, and this
by Wilson theorem, I already told by the last by Wilson theorem, -1 -2 p of minus k of mod of p. We are taking mod of p or not? Mod of p we are taking or not? So mod of p, p minus 1, p minus 2 we are taking. Okay?
Okay. Okay, sir.
So another theorem I will tell you. State and prove Lagrange's theorem. Let H be a subgroup of a finite group G. In the order of H is divisor of the order of the group G. So see here, let H be a subgroup of finite group G. Then the order H is the division of the order H of the group of G. So we have the finite. What is the meaning of finite group? Anyone tell me?
It can define.
It can define. So it is a defined group. Then the order of H is order of subgroup. So therefore, proof I'm writing here. We have G is a finite group. H is a subgroup of G. So there is a finite group. Therefore, H is a subgroup of it is a finite group. Therefore, order of H is equal to R. Therefore, H is equal to, we can write here H1, comma, H2, comma, and so on. HR. So H is equal to G. So therefore, order of H is equal to order of G. So therefore, order of H by order of G. So therefore, H not equal to G. So therefore, existing an element A1 belongs to G such that we have to taking. So H not equal to G means A1 not equal to belongs to H. Avuna? H not equal to proof అయినప్పుడు A1 and does not belongs to H. Avuna kada?
Yes, sir.
Therefore, H is equal to small h1 and small h2 HR. Therefore, capital HA1 is equal to HA1 A2, HA2 A2, HR A1. So H3 up to the condition we are taking HR A1. So therefore, now all the entries of H1 are, what is the meaning of distinct? Means different. What is the different distinct means? It is a different elements. So therefore, HI-A1 is equal to HI-A1 for some time I greater than 1. So therefore, HI is equal to order of HI. So therefore, A is a contradiction value here we are taking. So there is a contradiction value we are taking here. So therefore, A1 is equal to H1 inverse HI. HI belongs to H. This is J. HI inverse HJ belongs to H. That is a contradiction of to A1. It does not belong to H. So therefore, we can write H1 union of H union of HA1. H union of HA1. That is 2 order of H. Why? Because we are taking here 2. So then we can write 2 order of H. So therefore, 2 order of H is equal order of G. So therefore, the conditions it is equal to. So the theorem is H union of HA1 not equal to G. Therefore, their existing element A2 don't leave. A2 belongs to G. So therefore, A2 does not belongs to also H union A1. Am I correct or not?
Yes,
I'll have you understand. So therefore, What I am telling here, A1 is equal to HI inverse. H inverse means that contradiction of A does not belong here. So therefore, H1 union of HA1, that is 2AH, 2 order of H, that is of H union of HA1. It does not equal to G. Why? Because A2 belongs to G. And the mottam elements G lo undakapochu. H union of HA1 and 2 elements. So therefore, we can write here. HA1, H1A1, H2A2, H2A1, we can write, and so on, HRA1, HA2, H1A2, H2A2, and so on, HRA2. So with two entries of HA1 are equal to no entry of HA2 occurs in H1 and A1, H and HA1. So therefore, H union of HA1 and HA2, that is 3 order of H or not?
Yes, sir.
So therefore, the HA3 means it's a 4 order of H or not?
Yes, sir.
Then it is a finite or not?
Yes, sir.
Yes, sir.
So we can take that further step. H union of HA1 union of HA2 union of HAK minus 1 is equal to G. So K order of G is equal to order of G is equal to order of H by order of G. K. So this is the Lagrange's theorem. I think all of you understood.
Yes, sir.
Yes, sir.
Any more doubts? Any more doubts? Ask me. Any more doubts?
No, sir.
No, sir.
Any more? Any more? Please ask your doubts. Hello?
Yes, sir.
Ask me. Why? Because new topic will be started here. Please tell me and I will clarify the doubts. All of you understood?
Yes, sir.
Yes, sir.
Yes. Any more? Any more? Any more? Any more? Ask me. Any more, please? Okay. Okay, we will meet next Saturday. Okay?
Okay, sir.
Okay, sir.
All of you understood, I think.
Yes, sir.
Yes, sir.
Okay. Thank you.
Yes, sir.
Okay.
Right.
Okay, sir. Thank you, sir.
Ask me. Ask me any doubts. Tinana. Any more doubts? Ask me. Please. You can ask. I will clarify the doubts for today's class.
No, sir.
Okay. Varma, tell me. Ask me, Sultana, any doubts?
Sir, H union HA1 is equals to 2OH है ना, वो कैसा how it
1 minute, I will tell you. Don't worry. See here. How many HCS is there?
2H.
H union of HA1, that is 2 order of H. See here.
Okay.
H union of see here. H union of HA1, H union of HA2A. What is this 3 order of H? It is correct or not?
Yeah, yes. Okay, yes, sir.
So it is a 3. So it is a finite group. So because we are taking that up to the 3, 4 also we can take that. So it's a finite group. We can write K order of G is equal to order of G is equal to order of H by order of G. We can write it or not?
What, sir?
Hello? Any more? Ramya, Rajeshwari, please ask doubts. Nothing. No. Okay. All of you understood?
Yes, sir.
Yes, sir.
Ask me, Ramya.
సార్ నోట్స్ ఫస్ట్ నుంచి రాయలేదు సార్ నేను కింద లింక్ సరిగ్గా నాకు ఇందాక ఓపెన్ అవ్వలేదు అందుకని
Last day I will share the entire notes.
Yes sir.
Okay sir.
At the last of the class I will share. Okay.
Okay sir.
Yes sir. నేను కూడా ఇప్పుడే జాయిన్ అయ్యాను సార్. యాక్చువల్ క్లాస్ అయిపోయింది అప్పుడే.
15 minutes
లేదు సార్ మీరు చెప్పారు కదా క్లాస్ నోట్స్ అని అందుకని
Sir, this is first online class. Sir.
Tell me.
Sir, is it first online class?
Yes.
इसमें टाइम टेबल में 29/4 बोले हैं सर, उसमें लिखे हुआ है.
नहीं, this is the first online class. You don't forget it all of you, okay?
नहीं मतलब टाइम टेबल जो सेंड करे ना उसमें 29/4 भी है, 29/5 है शायद वो में भी.
Oh, yes.
Okay.
Anyone please?
Dr. Vijay.
Sir. Okay sir. Thank you.
Thank you sir.
Sir, notes sir first నుంచి చెప్పిన notes.
Thank you sir.
Thank you.